Terry Holbert from Ocosta High School, and today we're going to work with trigonometric identities. The first set of identities we're going to work with are called the Pythagorean identities, and they are probably the most useful of all of the identities. So we're going to start here with this basic equation. We know that x squared plus y squared always equals r squared. That's from the Pythagorean theorem, and so the reason these are called the Pythagorean identities. So I'm going to start with this equation, and I'm going to take each term, and I'm going to divide by r squared. So divide this one by r squared, divide by r squared, and divide by r squared. And if I do that, I get x over r, quantity squared, plus y over r, quantity squared, is equal to 1. And if you remember that x over r, that's cosine. So we have cosine squared plus y over r, that's sine. So we have cosine squared plus sine squared equals 1. And usually the Pythagorean identity is just written the other way around. So sine squared theta plus cosine squared theta equals 1. That is one of the most important Pythagorean identities that we're going to be using throughout this course. Now, if I go back and take that same equation, x squared plus y squared equals r squared, but this time instead of dividing by r squared, I'm going to divide by x squared. So I get 1 plus y over x squared equals r over x squared. And that gives us the Pythagorean identity, y over x, that's tangent theta. So 1 plus tangent theta squared is equal to r over x, which is secant theta. So there is another Pythagorean identity. And there is one last one. If I take x squared plus y squared equals r squared, I divide it by r squared, I divide it by x squared, so what if we divide by y squared? So we get x over y squared plus 1 equals r over y squared. And x over y, that's cotangent, and r over y is cosecant. So those are the three identities that are considered the Pythagorean identities. So make sure you know these and any other form that they could be written in. For example, I know sine squared theta plus cosine squared theta equals 1. I could add or subtract things to both sides, so I could say that sine squared theta is equal to 1 minus cosine squared. Or cosine squared theta is equal to 1 minus sine squared theta. So just be able to recognize these identities, but also their parts where we just add or subtract different values to the other side. Next, we have what are called the quotient identities. And to discover the quotient identities, sine theta is y over r. We're going to divide that by cosine theta, which is x over r. So when you divide fractions, y over r, you multiply by the reciprocal, the r's cancel, and you get y over x. So the first quotient identity is that sine theta divided by cosine theta is equal to y over x, which is tangent theta. And in the next one, we're going to basically do the same thing, but instead of sine divided by cosine, we're going to have cosine divided by sine. So cosine is x over r, sine is y over r. So x over r's cancel, you get x over y. So cosine theta divided by sine theta will always equal x over y, which is cotangent theta. Those are your two quotient identities. Next are the reciprocal identities. And we've already probably talked several times about these in the unit so far, but we know that sine is opposite over hypotenuse, which is y over r, and if you're in a unit circle, y over 1, so just y. So if you look at the cosecant, cosecant is the reciprocal of that. Instead of opposite over hypotenuse, it's hypotenuse over opposite. So sine and cosecant are reciprocals, so the identity becomes sine theta equals 1 over cosecant theta. The next one, then, since sine is the reciprocal of cosecant, cosecant's also reciprocal of sine, so we can do both of the reciprocal identities. Also, cosine, adjacent over hypotenuse, is the reciprocal of secant, and secant's a reciprocal of cosine. So we know that cosine is equal to 1 over the value of secant theta, or secant theta is the reciprocal of cosine, so 1 over cosine theta. And then the last one, tangent, being opposite over adjacent, and cotangent, being adjacent over opposite, they are also reciprocals. So tangent is equal to 1 over cotangent theta, and cotangent is equal to 1 over tangent theta. So those are your 6 reciprocal identities. Okay, so to use these identities now, we're given that sine theta is equal to 2/3. And we are also given that theta is between 90 degrees and 180 degrees, which is quadrant 2. So they're asking you to find cosine theta and tangent theta. So using your identities, see if you can find cosine theta and tangent theta. Since we know that sine squared theta plus cosine squared theta is equal to 1, we can use this identity to find cosine. So substituting in the value of 2/3 for sine, we get 4/9 plus cosine squared theta equals 1. So we'll subtract the 4/9. Cosine squared theta equals, the 1 I can make that 9/9, so that would give me 5/9. So cosine theta is either positive or negative square root of 5 over 3. To decide if it's the positive or the negative value, we need to look at what quadrant we're in. And we're in the second quadrant. And in the second quadrant, the only positive ones are sine and cosecant. So that means our value for cosine is negative. So our answer for cosine is negative square root of 5 over 3. Then to find tangent, we can use our new identity that says tangent is sine divided by cosine. So sine is 2/3. Cosine is negative square root of 5 over 3. If we dividing fractions, invert and multiply. So 2/3 times negative 3 over square root of 5 equals negative 2 over square root of 3, which we can simplify with. I have to back up for a second. Backing up, fixing something, sorry. Can't read my handwriting. starting over on this part here. So then, if we invert and multiply, 2/3 times the negative 3 over the square root of 5, the 3's cancel, so we have negative 2 over the square root of 5, which is negative 2 square root of 5 over 5. Okay, so there are our answers for sine and cosine and tangent. The next one, they're giving you that cosine theta is t over 2, and we are between 270 degrees and 360 degrees, which is quadrant 4. So I'm going to fill my signs in first, because in quadrant 4, cosine and secant are positive, and the other 4 values are negative. And it wants you to find the other 5 values in terms of t. Well, the first one, that's probably the easiest to do, is cosine and secant are reciprocals. So if cosine is t divided by 2, secant must be 2 divided by t. Next, I'm going to find sine. And I'm going to use my favorite identity, sine squared theta plus cosine squared theta equals 1. So sine squared theta plus t squared over 4, if I square the value for cosine, equals 1. So I'm going to subtract over the t squared over 4. I'm going to make this one a 4 over 4 so that I have a common denominator. So I will have 4 minus t squared. So then taking the square root, sine theta equals, now again, I know I'm in quadrant 4, so when I try to decide if it's the positive or the negative value, it's going to be the negative, and then radical 4 minus t squared over 2. Now tangent, as we already found out, is sine over cosine. So to find the value of tangent, we're going to take the value of sine, which we just found, divide that by cosine, do our invert and multiply, and we'll end up with, the 2's will end up canceling, so we'll end up with negative square root of 4 minus t squared all over t. Now the last two I can find by the reciprocals. So if I take the reciprocal of tangent to get cotangent, I would have t over the square root of that, but I need to make sure I rationalize my number. So I'm going to take t 4 minus t squared over 4 minus t squared. So when I invert that, I have the square root symbol on the bottom, which I can't have, so I multiply top and bottom by that square root value. And the same thing down here, I would have 2 over the square root of 4 minus t squared. So multiplying top and bottom, I would end up with that value for cosecant. Okay, next. Now that we have all the basic trig identities, we're going to be proving some of these identities using the ones that we already know. So this asks you to prove an identity by expressing all trig functions in terms of sines and cosines. And that's kind of a good basic fallback. If you're not sure how to verify or prove an identity, express them in terms of sines and cosines. So for this identity that we're going to prove or verify, cosecant. If I express that in terms of sines or cosines, I know cosecant is the same as 1 over sine. Sine and cosecant are reciprocals. Tangent, in terms of sines and cosines, is sine A over cosine A. And cosine is already in terms of sines or cosines, so I'm just going to make that I'm going to leave it alone. I'm just going to make cosine A, and I just put a 1 over it so they're all expressed as fractions. So if I multiply straight across my fractions, I have sine A cosine A over sine A cosine A, which is, they cancel, is equal to 1. So we verified that the left-hand side is equal to 1. So we're going to try another one. We're going to prove that 1 minus cotangent squared theta divided by cosecant squared theta is indeed sine squared. So 1 minus. We need to do a little substituting here. And since we want sine squared when we're done, it'd probably be easiest to go into sines and cosines again. So cotangent is cosine over sine. But since the cotangent is squared, we have to square both the sine and the cosine. Now cosecant is 1 over sine, but since it's cosecant squared, it would have to be 1 over sine squared. So if I do my invert and multiply, we have cotangent, which we expressed as cosine over sine, each squared, multiplied by sine squared theta over 1 by inverting the denominator up. The signs cancel, sine squareds, so I get 1 minus cosine squared theta. Now, we want to show or verify or prove that that is equal to sine squared. And if you remember our Pythagorean identity, sine squared theta plus cosine squared theta equals 1. So if I subtract over cosine squared, that is equal to sine squared. So this is sine squared theta, and we just verified that identity. Here's another one that we're going to be working on, and if you look at this, if you're trying to decide which side to work on, usually it's easier to take things that are not in terms of sines and cosines and express them in terms of sines and cosines. So I'm going to start this time with the right-hand side and try to make it equivalent to the left. And the first thing I notice is 1 plus tangent squared b. That's a Pythagorean identity. So I'm going to take the top there. I'm going to leave this one for a minute. 1 minus tangent squared b. Well, 1 plus tangent squared b is secant squared. So I tried making that a little bit simpler. So now, since I want my answer to be expressed in terms of sines and cosines, I'm going to take tangent squared. I know tangent is sine over cosine. But again, it's squared, so that means I have to square both the numerator and the denominator. And secant, I can express that as 1 over cosine, but since it's secant squared, I have to do 1 over cosine squared. And invert and multiply. So I have 1 minus sine squared b over cosine squared b. I'm going to take that whole thing and multiply it by cosine squared b over 1. Be careful not to just cancel the cosine squares. This cosine has to get distributed to both of those. So the cosine squared times the 1 is cosine squared b minus, when you do take the cosine squared times the sine squared over cosine squared, the cosine squareds do cancel, and you get sine squared b, which is what we were looking for. So be careful to make sure you distribute if you're multiplying by a quantity. Here's another one, And this one, it may be difficult to decide, should I do the left side or the right side? Because they look very close to each other. And so sometimes it doesn't matter which side you start with. So I'm going to go ahead and start with the left side. And I know my Pythagorean identities tell me that sine squared theta plus cosine squared theta equals 1. So I know cosine squared theta is 1 minus sine squared theta. So keeping that in the back of my head as I'm looking at the 1 plus sine theta, sometimes it's nice to be able to get that to look like one of our Pythagorean identities. So what I'm going to do here is I'm going to do a little trick where you multiply top and bottom by its conjugate. And you'll see why here in a minute. So I'm going to multiply top and bottom of this fraction by 1 plus sine theta. So I have 1 plus sine theta times cosine theta on the top. And on the bottom I have a 1 plus sine theta or minus sine theta. And now we're going to multiply that together. So 1 plus sine theta, 1 minus sine theta is 1, positive sine theta, negative sine theta. So those are going to cancel, minus sine squared theta. So on the numerator again, I'm just going to write that down. So the 1 plus sine theta times the 1 minus sine theta became 1 minus sine squared theta. But remember that 1 minus sine squared theta is cosine squared. So I'm going to substitute in cosine squared theta. Then if you notice we have a cosine on the top, a cosine squared on the bottom, so I can cancel one of the cosines here with one of them there, but that still leaves me a cosine on the bottom. So my final answer, which is what we were trying to get, is 1 plus sine theta over cosine theta is equal to what we already had on the right-hand side. So we verified that they are equivalent. And let's try another one. Here, let's work with the left. Again, sometimes it's easier to take fractions and add them together and combine them and then hope that we can see where to go from there. So here, to add fractions, I have to have a common denominator. And my common denominator is 1 minus cosine b and 1 plus cosine b. So this side I'm going to have to multiply by top and bottom by 1 plus cosine b, and this one by 1 minus cosine b to get my common denominator. So there's my common denominator. On top, the 1 times is 1 plus cosine b still, and then plus, and then the 1 times the 1 minus cosine b is still 1 minus cosine b. So simplifying the numerator, the plus cosine b minus cosine b cancel. So 1 plus 1 is 2 over, and if I were to multiply out my denominator, 1 minus cosine b times 1 plus cosine b is 1 minus cosine squared b. Going back to our Pythagorean identities, we should start recognizing that. 1 minus cosine squared is sine squared. So I'm going to write this just a little differently for a minute. I'm going to write this as, just so you can maybe see a little better where this comes from. But would you agree that 2 over sine squared is the same as 2 times 1 over sine squared? And the reason I did that is because I want to take this and change that 1 over sine, that's cosecant. So we're almost there, and then we're almost out of room here also, so I'm just going to swing this up here for a minute. If you look at what we're trying to get, 2 plus 2 cotangent squared b. If you think back to your Pythagorean identities, we had a Pythagorean identity with the word cosecant squared in it. And that identity was 1 plus cotangent squared. So in place of the cosecant squared down here, I'm going to substitute in 1 plus cotangent squared. And then if I distribute, I have exactly what we were trying to prove. So I hope that helps with showing you a little bit about verifying identities.